14-57576.
The
Captivating construction for
OGs. I'm Ian.
I'm Eric.
I'm Scarlett.
I'm Bryce.
I'm Bryce.
I'm Christopher.
We started out this season by having a Scuba International member talk to us about a few problems they and their partner organizations face with ocean exploration. Each team member contributed to our Microsoft Whiteboard site, brainstorming ideas for potential research problems. We went around the room and each team member spoke about the issue and why they liked the topic.
We had 2 of our team members take a week to research 3 of the ideas that seemed most impactful to ocean exploration, and then our team voted on our official research topic. The problem we chose to solve was coral bleaching, so we set out to find a solution to help prevent coral bleaching.
We researched what coral bleaching is and ways to prevent it, and then we consulted the experts Katie Cooper, the CEO of Scuba Nuts International, who validated its significance, Shannon Dixon, a PhD biology student at the University of Ohio, who gave us detailed information on how shading prevents bleaching, and Bryce Schaefer, an aerospace engineer who refined our ROV and shading device designs. The NOAA talk provided the first themes, inspired us to incorporate AI into our design.
The problem we are addressing is coral death due to coral bleaching. Coral bleaching occurs when coral rejects the symbiotic algae they rely on for survival due to temperature changes, pH levels, and UV rays. Coral is a keystone species, meaning if it didn't exist, 25% of all ocean habitats would disappear, ecosystems would be disrupted, the fishing industry would suffer, and coasts would be eroded.
Our solution to this problem is the creation of an ROV that can work alongside multiple large shading devices that migrate over large coral reefs to shade large groupings of coral. In Kiribati Reef specifically, we estimate that it would take about 3,000 shading devices that are 30 feet by 30 feet to cover the whole reef over a 12-hour period. We're going to start with about 100 shading devices and 25 ROVs. These ROVs could be automated or manual, requiring a controller depending on the circumstance.
We created a DIY ROV model using PVC piping. The ROV has motors for back and forth and vertical movement, 2 cameras for AI integration, and a waterproof box in the back for electronics and weight distribution. The PVC pipes carry the wiring needed. Additionally, in Blender, we rendered a rough design of the shading device in ROV and then animated those devices in Unity.
The ROV and shading device will stay in the water, facing wear over time. To prevent this, we'll use high-quality materials, protective coatings, and sensors to monitor issues like overheating. If a problem is detected, GPS can guide a technician for repairs. The ROV and shading device will come in 3 different sizes, 7.5 feet, 15 feet, and 30 feet, for flexibility across different reef conditions.
The estimated grand total of the ROV would be about $4,000 and $4,000 per shading device. The estimated power consumption of the ROV is about 2,900 watts every 12 hours, which is how long it would be operating in full before going in battery saving mode for the night, and the shading device taking up about 3,750 watts every 12 hours. Our project is able to make up about 6,600 watts, assuming it is a sunny day for all 12 hours.
To identify coral, we use YellowV5, which is an AI model trained to identify objects and images. And in our case, it will help us identify the type of coral and assess their health. The current version is free, but a new version is coming out soon, which we need to evaluate as has lots of features that will be useful for us. We're also currently looking into photomosaics as they will help us be able to show the long-term transformation of coral reefs.
To fund this project, we have contacted organizations like Coral Marine Aquarium, SeaWorld, and Tampa Aquarium. We also plan to apply for grants by presenting a video demo, detailed models, and project plans to potential sponsors. The project's focus will be on its environmental impact, and long-term benefits.
We plan to start the project in Cayo Ratones Reef, which is a small secluded reef off the coast of Puerto Rico. It is perfect for our pilot project due to minimal human interference, significant sun, and an existing bleaching problem. To prevent boater damage in busier areas, we will use reflective materials and issue warnings via mobile apps and radios. The device will also have cameras to identify violators and charge fines. To prevent severe storm damage in busier areas, the ROV and shading device can relocate to safe zones. Thank you for listening. Any questions?